Okay, this is question number 39 in your review packet, and I need to correct my answer for 39 because I made one small mistake. So if you're looking at your answer choices here, which of the following differential equations would match with this given slope field? I was looking at the slope field and I noticed that it looked kind of like a parabola. It also looked kind of like a fourth degree because fourth degree functions are basically the same as second degree functions. What I didn't notice and what I didn't pay attention to is that I noticed it, but I didn't think about in terms of the equation that we would get the bottom half for y is less than 0. It becomes an upside down parabola. And the only way that can happen is if it's a negative x squared. You guys know all this. So the answer choice that I had circled and said was correct was letter choice D. If you actually solve the differential equation, I'm going to do that real quick. We get dy dx equals x plus 1 quantity cubed dx because I'm multiplying by dx, so I can solve the differential equation. And then I'm going to take the integral of both sides. And I get y equals x plus 1 to the fourth over 4 plus c. And when we look at that, that is, of course, a fourth degree equation. That's where I'm saying I saw this, and I thought, okay, that looks like it could be that. Depending on the plus c, it would be up or down. The problem is that the only way that can become an upside down graph would be if there was a negative in front. And the plus or minus c is only going to shift it up or down. It's never going to be an upside down. So for that reason, we have to cross out letter choice E. E is not the correct answer. So the other way that you could think of that is you could say that anything that's in terms of x is going to have a vertical, because for every x value, a vertical column of slopes. So that kind of works right here. Well, it definitely works right there because you've got all 0 slopes. But if you go to a different column, like let's just go over to x equals 1, your slopes are not the same up and down that column. And if your slope, your dy dx, your slope, that's our calculus notation for slope, if your slope is dependent only upon x, as it is in choice E, there is no y there. If it's only dependent on x, that means for x equals 1, all of these slopes would be the exact same, just like we have here. So, another reason that we should throw out choice E. So now I'm stuck with looking at A through D, which are more complicated because they're in terms of x and y, but make more sense, obviously, in this scenario. So between those, looking at those, I focused on, as I often do, the slope of 0 is usually the easiest for me. So I said, okay, the slope has to be 0 whenever x is negative 1. And if you look at that, that means that it's not dependent upon y, but there is a y in our equation, so we have to deal with that. Well, I ruled out choice A right away because a negative 1 for my x value, let's just make our y 3, looking at this point right here. Well, negative 1 times 3 gives me a negative 3 for my slope. So I'm just kind of picking points and saying, okay, that doesn't make sense here. So if you look at the next ones, using Bradley Parker's technique, I would choose choice B or C because those are similar but have a different sign. But seriously, if we look more closely at it, if I'm multiplying by negative 1, that's really just changing the sign of my y value, whatever my y is. So that first term is just going to be the opposite of y, whatever y is. If y is positive, it's going to turn it negative. If y is negative, it's going to turn it positive. So let's just pretend y is positive. Turning it to a negative means I would have to do what to cancel it out to get back to 0? Well, if I add y, then that's going to make it 0. So if you look at choice C, negative 1 times y, if your x is negative 1, is going to make that really just a negative y. So you have a negative y plus y. And that's going to give you 0. Only when x is negative 1, but that's the only column of slopes I'm looking at right now. This is going to be a negative y minus y, which is not going to be 0. That's going to be 2y. So that's not 0. And then this one's going to give you a negative y plus x. And I have no idea what that's going to be, but we can't guarantee that's going to be 0. It's only going to work in specific cases if x is the same as y. So that's allowing me to select answer choice C as my correct answer choice. And that's really just by looking at that one column of slopes. So I apologize for my wrong answer. Hopefully that helps you to understand how you can deal with, I know it's more complicated when you have x's and y's in there, but how you can simplify the process by looking for common slopes. And of course you could try other points there too. So that's not a wrong idea, but this is probably the easiest way to go about it.